I think we had one with at least an issue. What I can do, what I'll just go ahead and do, is I got EVO pulled up, and what I want to do for the license, so you can grab, depending on how you have the firewall set up, I'd probably just, if you're having issues with the one that needs ports open, just grab that other license string and put it in here, and I'll show you where that goes. So you got EVO pulled up. You'll just go File, top left, go to your license manager. I think if you don't have a license in general, it'll just pull up the license manager automatically when you try to open EVO. But what I'll do here is I'll grab that license that I sent out, which was this one. And if anybody needs this, I can send it to anybody again. So this is the one without opening ports. All you'd have to do is click set. License successfully. I think you'll have it more like this, where it says you have a viewer license out. All you have to do is go in here and grab, make sure you're not using that viewer floating license. Use that EVO timed. You just click checkout. You'll see that it's this is good to go now that you know your EVO license is working. Another way to check is if this button here, this is our import wizard, this green down arrow, if that's grayed out, that's kind of an indication of you're having a licensing issue. It's typically you're on a viewer license if that's the case. The other thing that I'll set up kind of before we break off for lunch is if anybody, so I'm going to go into File, File, Project Settings. I'll open up this window here, and I'll go over to True View. So if you're wanting to follow along and use POSPac, there's a couple things you're going to have to do. Most likely, if you did download it, it should automatically point to the batch. Or I know somebody had a POSPac local license, it may automatically find it. Typically, even if it does, I'll just go out and browse for it regardlessly, and then just point to that. Go into POSPac 8.6 and point to that POSPac batch. That way I know it, make sure it'll work. What I'll be using, I believe, is Cloud. As long as you downloaded that from our FTP, you can use that. If not, we have an option for that as well. You can just watch me do it. The steps are pretty much the same between local and Cloud. You'll just be skipping a POSPac chart, and I'm going to be going over that, so you don't really need it. And it also produces this trajectory file. What we can do is we can import that trajectory file into the flight and not have to run POSPac since we've already ran it. And I'll show you how to do that as well. What I also need to do, hopefully everybody got the email from Brecken. If not, I have everybody's login for that to do that login. So what we're going to need to do, if you're going to want to follow along with that cloud processing at least, what you'll need to do is I'll go in here. You're going to be creating this TV training account, so you won't have any here. The way to create this is just click this plus. Account name can just be TV training, and the URL is https://aragon.net/TV training. So everybody will need to, if you want to use POSPac Cloud, you'll have to create this account. You'll just click OK, and it'll add that in here. And later on, when we go into the POSPac step, you'll have to log in to your account with that Reckon information, and I have everybody's. If you should have got sent an email with the password, but it'll be whatever email you signed up for this webinar will be that email, and I'll have the passwords if anybody needs them. Or if you went into that email and actually changed it, which I think is possible, you just got to know that password. Like I said, if it doesn't work, this way we can get around it by just importing the trajectory file. But that's kind of the background. I know who was it that had that issue? It was Elijah. Did you get that figured out, Elijah? Did that help, or did you still need help with that? Because if we need help, I'll probably what I'll do is I can cut off. We'll break for lunch, and then I can help you out.
So we're going to be running, if we have POSPac already installed, it's going to load from within True View, or we're going to be using POSPac independently?
It loads into True View itself. You don't have to. You just have to point to it. So do you have I believe you're the one with the you already have the 8.6 local kind of copy?
Yes.
Okay. So what you'll do, are you in this dialog here?
Correct.
Did it already point to a oh, not that one, sorry, this top one, did it already point to a batch file here?
Yeah, yes.
Okay. Most likely it'll just work. Typically, if we see an issue later, like it'll give you a POSPac, kind of just a generic error. You may want to just go ahead and do it if you just click this ellipses out beside and go ahead and click your POSPac batch and open, just repoint to it. And then you kind of just avoid that
Okay.
in general. As long as you got that, you should be able to use POSPac. This is a local sensor. This is an own sensor, so you don't have an issue with that.
Perfect.
So
okay, thank you.
Yeah, no problem. Looks like Elijah is good. Okay, so I think we're actually fairly ahead of schedule, which is good. Gives us extra time. So I think what we'll do is break for lunch. Let's see. I think if we come back about an hour, probably hour and 15, so 12:30 Central Time. I think that'll be good. Let me see if I've got anything else that I need to quickly go over. Oh, that looks good. Let me see. Yeah. Okay, yeah. So what we'll do, we'll break for lunch here shortly. What I'm gonna do when we get back is I don't know the best way to do this. I've got a couple ways we can. I think I'm gonna go through the cycle kind of slowly. I would go through, I'll go through slowly, kind of explaining all the steps for the first cycle. I'll let everybody kind of get to know how to use the software. And then what we'll do is I'm also going to show you how to do a multiple cycle processing. And on that second cycle, what I'll do is I'll do it a little bit faster, so you see how quickly it typically is. Like I said, you could probably get some of this stuff depending on the POSPac, if you're using local or cloud. They're typically pretty quick each, depending on your internet for the cloud. But I mean, we can get a point cloud in probably, I'll be a little bit more conservative and say 20-30 minutes, depending on the flight, how big it is. We can get to that point pretty quickly. After that, what we'll do is kind of go through what you do to export a photo package for your ortho mosaics, and that's kind of what we've got planned. I'll go through some of the buttons, some of the navigation tools. That's kind of what we'll go through. We'll kind of go through a little bit of the horizontal vertical check, and kind of get that done. Yeah, I will send that to you really quick, Chris, and I'll make sure I'll I think we're good to break off for lunch. If anybody has an issue, just stay here. But be back at in about I'll say 12:30 Central Time, about an hour and 13 minutes or so. And I'm gonna stay on and help anybody if they need it. All right, Chris, I'll send that out right now. So before lunch, we covered the hardware of the sensor, field operations, go out and collecting that data. Now we're gonna pick up with our post-processing of that data in True View EVO. So that's the software package, of course, that you get with your True View system. This afternoon, we're going to walk through from when we first get that data back from the field through to having to colorize point cloud. And there is, of course, a second module to this class. I'm sure most of you are aware, but if you're not, it goes into more in depth. It goes into ground classification and some derivative products. That will be next week. I believe it's, let me check the exact date. So that is on Wednesday, April 21st, so next Wednesday. If you're not already registered for that, make sure you do that. If you're not, you can also just say so, and if you don't know how to register, we'll get you there. Just let me know, and you can either send me an email, send in a question, or if you're not sure, you just send me an email, and we'll figure it out. So what you'll do in that class is just pretty much picks up where we're stopping off. So you'll bring in the LAS, and then we'll start doing some classification, some outputs from there. So there's a couple things that I want to walk through to get us set up here. I kind of went through it a little bit before lunch. Hopefully everybody's software is working correctly. If not, we'll just say so. We'll as long as it's not a major issue, we'll try to get it done quickly. If it's more major, I'll get somebody to split off with you and get you settled. That way we can see what's going on. So I do just have EVO that's launched from my desktop here. So it should look like, as long as you have the license active, this is what should be coming up. So EVO is just, it does run on our LP360 engine. If you don't know what LP360 is, it's just it's our main product that we sell into the GIS market. It's a point cloud data analysis tool. So EVO is built on top of that engine. So essentially it is LP360 with some additional tools to do the preliminary processing of your True View data. So in True View, you're getting all the capabilities of LP360. So it's a great combination of tools for working with both your True View data, but also once you get a point cloud and doing a lot of additional value at working the workflow. So let's talk a little bit about that data set we're going to be working with and give you a bit more overview of what the data looks like. So the data that was in the download link, the only one we're really interested in for today, I will mention that other data set, the shop, that data set will be used in next week's class. So feel free to download it between now and then. It's a lighter data set. But the one that we're going to be interested in today is the DAM data set. Not all of it, but the majority of what's in here, or at least most of it. There's some extra like cycles in here that way you can practice with. I think there's a total of 5. We're only going to be working on 2 for today. So we left the other ones in there just so you're able to use it if you wanted to practice on some data. So what we have here, we have an ortho mosaic that's already created. That's in here. We have all the raw cycles. we have one as a raw cycle and all the other ones are in an archive. The reason for this is so I can show you how the archive process works. Got a few reports. We'll see these later. Not too interested in them currently. We got a survey folder that has our Opus report. So this is where going to be for our use for our survey nail. And then we have some checkpoints that are in a text file that we'll be bringing in as well as just a text file here telling us what this project was flown in and what it needs to be processed in. Okay, let's see. I mentioned before, go drop into this file here, some of the information here that's in this these cycles. We kind of went over that. Some of the important things. Some of the stuff that EVO will be using for this processing. Okay, let's see. So we started in the project settings earlier for lunch. Of course, it pulls on my other monitor. Let me drag it over. It is important if you're wanting to follow along, especially with POSPac cloud version. If you're local, you don't have to really worry about this top part. If you're using cloud, make sure you have that TV training account. If you're not too worried about running that right now, you don't have to. I'll show you where to import the trajectory file, and you can skip over that step, and you can just watch how I do it if you'd like. So there are, if you notice, there's a lot of buttons here. It's just like a lot of other GIS softwares. There's just a lot of buttons. So I want to try and focus on the ones only those ones we're going to be using today. And most likely what I'll do is I'll drag the toolbar off so you can see which one I'm using. If you ever have an issue where you don't see a toolbar that I'm using, if I have it dragged off, you can take note of the name of it, go into your view tab up here and make sure it's turned on. If it's already on, just click it on, or click it off and click it back on and see if you can see it jump into your field of view. It's typically how the easiest way to find them. I know mine are going to be set up in a different way because I pull them off for training and just dock them in a random location mostly. I will go ahead and mention, since we're already up here, this help. There is a built-in help system. Fairly simple, just like a lot of other help systems. If you got something you want to look up, you can search it. That's like something like point cloud tasks. You can go through and look at some articles about those. So let's say adding a task, display, and it'll go through and kind of give you some background information on whatever it is you're looking for. Another place to look if you've got questions about a certain thing on the knowledge base, you're bound to find it if you search it there. It's a good resource for some self-learning and digging into some of these different aspects of the software. So, okay, we'll go ahead and go and start into bringing this data in. There's a couple ways to do this. We'll be going over both. First, I'll go over how you bring it in to process it from a raw cycle. And then later I'll show you how to bring it in. We already have some process cycles that we're going to bring in, and how you do that if you're bringing it back in, if you're just bringing the LAS or something like that. Very simple, but we'll go over that. So the workflow goes kind of, it's this toolbar here, one that starts with this down green arrow. It's going to be the True View workflow toolbar. And we're going to be working pretty much left to right. So it's set up pretty nice, so you don't have to do too much other than just click the next button in the sequence here. Okay, let's see. What I'm going to start with is the archive manager. If you see, I'll pull it off here, this True View Utilities, it's this folder with the down arrow. I'm going to go ahead and click that and bring that up. What we're going to do is, let me remove this one. What we're going to do is set up an archive. So show you how to do this. So you can do this either on a network drive or a local drive, whatever you like. You don't even have to archive if you want, but this is just kind of just to introduce you into the archive manager, and we'll be using it later this afternoon. So what I'm going to do is I'm just going to go in here over here and click add. Now you got to click these ellipses and point to the folder we want to use as archive. If you go into that training data set, into the raw cycles, you'll see that there's a file or a folder here called archive. If you select that folder, and then we can just name it. Actually, I'm gonna do today's date. Give it a name, click OK. Now we'll see that that's been added. If I click here, I can actually see what's in here. So we got 4 cycles that are in here that are archived. So what the archive is doing is it's going to compress them and make it a little bit more manageable in space and put it in here. So we'll be using this later. So it's good to set this up. You don't necessarily have to, but this is how we're going to be processing our multiple cycles. So if you're wanting to follow along with that, I would go ahead and set this up. Okay, let's see. So what we'll see here, there's a lot of data that gets stored with it. You can, some metadata, start time, end time, the sensor number, the firmware number, whether you put an observation file, if you put your images with it, number of images, some SRS data, and some coordinate data. That's all stored in the archive for you. So whatever you bring in with the cycle and archive with it will show up here. Okay. So now we can close this out. Now we have that archive set up. I want to dock this back up here. Well, now we're going to go down to, or back to, is this True View workflow toolbar, the one that's starting with the green arrow. What I'm going to do is I'm going to go ahead and click this green arrow. So this is the True View import wizard. This is where you're going to start with all cycles, all new cycles. When you got several options here, I'll go through them all so you understand what they are. The first section just refers to importing cycles. These top 3 options, or these are the 3 options you got: this one, and this one, and then these 3 options apply to this guy up top. So we'll be focusing on this one for now. This is where I'll be importing our folder that is our cycle. And if I'm importing a cycle, I have 3 options. I can just archive it. I can archive and import it. So that's going to be archiving and then importing it into your project, and creating a new project with that data, and also, but of course, creating that compressed archive folder. You can also archive it only. So this is, you're not importing it, you're just archiving it. Whether that be maybe if you're not interested in or don't have the time to go through it at the moment. You can just, with processing at the moment, you can just archive it for now and back them up. Or I can just import it. So this is no archive at all, you're just importing it straight in here. Now you'll still have the raw cycle, at least on the UMS. So what we're doing here, we're gonna be importing copies of the data. Or with our new project, it's gonna import a copy of the data. So you still have the raw cycle if you still need it. So. Okay, I may wanna, so the next option here is maybe you wanna work on a cycle that's already archived. So you archived it only earlier, now you wanna bring it in. This third option, you can do that. You can just import from a archive. We'll be exploring that option a little later. And then there's this third option. It's for non-True View sensors. So we have a workflow for the only a couple sensors at the moment. You got it, we call them guest sensors. You got the Phantom 4 RTK. Well, it's basically any RTK DJI aircraft. Well, I shouldn't say any. You got these three options. We can do some PPK processing with those drones. With the P4 with as it is. I haven't done a 210 yet, but I have done an M300 with a P1 camera, so we can bring that in and process that data. You're just at that point just making a photo package to export to a say like Pix4D or Metashape though. So for now we'll just be importing a cycle from a UMS sauce folder. Now I could archive and import this cycle, but it does take a little time to compress it. So what I'm gonna do is I'm just gonna import it. So click import, click next. So this is the next section here. We just gotta go and find that cycle now. And what I can do is I can go in to browse, go to my training data, the DAM, raw cycles, and this cycle that ends in 559. I can grab that and select folder. What I'll do is go in and see if it can find the images and where it expects them to be. And you can see that it automatically found them. Okay, I can click next. Now what we're going to be doing is selecting a output project location. So you can set this anywhere. Where I'm going to put it, I have a training projects folder. I will actually create a new folder in here, give it a date. Select that folder. And then if you want to pin something on the end of this or change the name, you can. I'm just going to leave it as this. All these cycles are unique in name according to the date and time that it was flown. So it's date, year, month, day, and then hour, minute, second, and UTC time. Okay, so we can just click next here. Next part here, I'll say anywhere you see description, this is just a for you, or if you're leaving notes for somebody else that's processing, maybe you flew it and you're just archiving it. Give it a little bit more descriptor, or maybe if you fly site multiple times or have a site with different areas, you might want to name it. I'll leave these blank for now because they are not mandatory. They're just optional for you. They're just extra information. Positioning strategy over here. So this is if you plan on using your base station, you'll be, of course, clicking that option. If you're planning on using Smart Base or PPRTX, make sure you click that. What I'll now be doing is selecting our spatial reference system, which if we look in our training, here. If you look at this text file, we can see that we're wanting to be in 93 2011 state plane Alabama East meters and ellipsoid meters. This is just what this was flown in and what the checkpoints are in, so that's what we're going to makes it easier for showing off. But of course, you can bring it in whatever you feel comfortable. I can click this drop down. You'll see these are, you won't have this yet. Whenever you start using these coordinate systems, your most recent ones will be stored here. What you'll have to do is click this ellipses out here, and then you should click OK, and it should take a second, and it'll open up our coordinate reference system manager. This kind of dialogue here that you're going to see, we'll see it in multiple places once it pops up. Okay, it popped up here, so it should look like this. So for this one, our horizontal, so we'll go projected, state plane, NAD 83, 1983, 2011 meters, and it should be Alabama East. So you just click that, and then the vertical is ellipsoid meters. So once you have those, you click OK. It'll fill it in here. Make sure that looks correct. It does. Give you all the information about that. And you're good to click next. So this is where if you notice how I had in one of my cycles, I had my observation file put into the, if you put it into the system folder, which I'll go show you. You'll notice in my system folder, I have my observation file here, this .o file. So this is pulled from my base station. If I put it in here, EVO will automatically grab it for me and bring it in. But I also can just browse to it. In this case, I'll do that. I'll click the plus. Then I can go into my training data. The dam. It's going to be under survey. Actually, sorry, wrong spot. It's in raw cycles. RINEX. This is .o, 20.0. You click open. You make sure to put your base station antenna height. We use a fixed 2-meter pulse, so ours is going to be 2 meters. Ancillary files, that's just kind of extra information. Say you have something like our Opus report and you want to add it in here, you can do that. We're not going to do that for now. And click next. This is going to be our reference point. So this is where our base station was sitting on, the point that it was sitting on. Once you have some put in here, you can click this drop down and select them. So if you used them before and you fly a site multiple times, you can store them here. For this one, we'll have that add. It'll pull up this menu. All you have to do is click add. And I'll just give it a name. 210414. You can give it a description if you want, and then you can either enter it manually if you know that, or load from Opus. That's how we will do this one. So this will be in data, the dam, survey folder, and it's this Opus, so it'll pull it straight from this Opus file for us. And click open. You know, see these values filled in.
Michael, sorry, the base station data should have been in the survey folder.
No, sorry. Yeah, let me click OK here. Okay, let me back up for you. So if you go, it is in the dam, and then in raw cycles. Sorry, that was my fault. Okay. And then in RINEX.
Got it. Thank you.
Yeah, no problem. Okay. Let me pull that back up. So that was this one. So once you have this, if I need to run this again, all you do is click add. It'll pull this file up, or this dialog up. You click load from Opus. In that survey folder is this opus.txt. You can click open and it'll fill this values in for you. Once you got that, you can just click OK. OK again. It should automatically grab it, but if it doesn't, just drop the menu down and click on it. This approximate distance kind of gives you just a, this is more here just for your reference to make sure you're clicking the right one. Like, say if I clicked one, this one's in Tallahassee, Florida, and I see that it's 384,000 meters away, I know that I'm not using the right base station. That's kind of why that's there. Description, you can give it a description if you want. You still don't have to. That's how all the descriptions are. And then you can just click finish. It'll ask you if you want to continue to import it into a new project. And we do, so we click yes. And that'll run through the file. You can see down here copying all the data from your cycle into your project. Go from the laser to the images and all that. So as it does this is going to create some layers. You'll see them pop in and some data fill in as it populates. It should only take a couple minutes at most, depending on how long the flight is, of course. But now you can see it's copying all the images. Doing it a little slowly, but not too bad. Okay, it's finishing up here. Took a little longer than I expected normal, but you'll see that it added some layers on the left here, and it brought in a WMS layer as well, just for some context. So this central view here, we're seeing what we call this map view. It's just a top-down planimetric view of our project. And it's, like I said, it's created some of these additional layers here in our project. Just like a lot of GIS softwares, you'll know the concept of the layers. And this will be the table of contents on the left that we'll call this, or TOC in the bottom. You'll see. I may refer to it as either. We'll take a look at some of these. So we'll create a stations layer, a photos layer, trajectory log, and some the trajectory lines. So it's just connecting the dots of these trajectory points. The log layer is really just a debug tool to assist with some support things or some troubleshooting issues. So what I'm going to do, I'm going to turn that one off. Basically taking the in-flight logs and making them accessible. So generally you can just turn that one off. You don't have to leave that one on. So we don't really want the cameras themselves. We can turn these photos off. So the photo stations is recording the position when an image was taken. And we have dual camera systems, so we essentially have 2 photo centers for each exposure center, 1 for each camera. So we actually simplify that by creating the camera stations. So it has 2 images associated with the camera station. You can go in and look at the individual cameras with the photo centers that I typically turn. I typically turn that one off. And by turn off, of course, I just mean you uncheck it over here. There's also these trajectory points. I typically don't use them. I'll turn this photo station off so you can see them. What I typically would use if I turn these off, you can see the trajectory line, so it's just connecting those dots. I'll typically use that for my reference. I'll turn my stations back on. So this is kind of our course trajectory, this line here. It's a 1 position per second or so update. So it just gives you a rough, and we'll be refining this later with the post-processing with our positionings. So I have no LIDAR, of course, yet. We haven't gotten to that part yet, but it will be quick. I may want to do what I may want to do. I kind of already did it with the field check with the images, but I can actually take a quick look here. I'm just kind of give you some information, and let you know this features works, or that there's these kind of features. Make sure our images look good here too if you want. What I'm going to do in my table of contents, I'm going to left click my stations layer, and then go to feature analyst. Generally, if you just right click any layer, it'll kind of give you some options based on that layer, just in general. Kind of some shortcuts that you can run for that layer. So I'll go feature analyst. What this will do is it'll pull up this dialog here. Feature analyst is pretty much exactly what it sounds like. Just a tool that lets you look at the features on a layer and presents any of the attributes or metadata about those features. For an image layer, it's like this. It's going to actually look at the images that are associated with each camera station. I can actually do this in a couple of ways. I can just select a row here, and it'll pull up the 2 associating cameras or 2 associating images. Or what I can do is I can actually go in here. If I scroll in and select one of these photo stations and click select that, it'll actually drive my my feature analyst here and show you those pictures at that specific time. Not something you need to do. Like I said, if you looked at them earlier and the images look fine, you probably don't have to look at them here. Just kind of giving you this, showing you that you're able to do this. Of course, you can move these around and look at them, or change the, if you want to look at them here, click this pan option. But it's there, okay. Okay, let's see. Next, we'll kind of jump into the next part of this processing. So this is a part. If you don't have POSPac installed, just pay attention to what I'm doing, and we'll get you caught up afterwards. It's a little bit later down. There's another step you can take to bring in the information we're about to get. If you want to run POSPac with me just to see how it works, you'll click this next step. This POSPac processing wizard, or the PP button. Just click that. It'll bring up the dialog. You'll notice on it, I can't drag it over right now, but you'll see it saying analyzing TO4 file. Okay. Once it does that, it'll bring up this menu. So if you're using a local copy of POSPac, you don't have to worry about this step. You'll just select local. If you're using the cloud version, what you'll need to do is click cloud here. And that login, you should have got an email from Reckon with a login. What we'll need to do here is this account here. We set up that True View training. What you want to do is select that. And using that email that, whatever email you signed up for this course with, put that email in here, and the password should have got emailed to you. If not, let me know and I'll send passwords out. I'll let everybody catch up with this and take a look that wants to run POSPac. Okay. Well, if we have that set, what we can do next is, so this information is just the cycle name it pulls from our project. This is the TO4 location. Processing mode here depends on what you're processing in. We're going to be using a local base station, so single base is what we'll pick. I'm going to use local just to speed it up on my end. Everything's pretty much identical with these besides this login part for the cloud. Everything else up after that is the same. You'll see it'll give you your sensor model, the type of sensor you flew, whether the serial number, hardware type, whether it's owned or subscription, start and end times, and total minutes. And as well with cloud, it'll give you some, I'll click that back on. It'll give you your current cloud balance for your account and the estimated cost of the flight. So if you're using cloud, it'll be so many points per flight. However, you'll notice it says duplicate task. We've processed this once. As long as we're processing with the same processing mode, we don't charge you again, of course, for that, for processing that same flight. Now, if you swap to, like, say, Smart Base, you'll see it'll give me a price here. I'm gonna run local. These other options are debugging options that are in my version. I don't believe will be in yours, but we can click next. If you didn't bring in the observation file earlier in the import, we could bring it in now. Same with the survey now, we could do that. Whatever you put there is going to come into here. All these other options this is just kind of double checking the information we selected earlier. That looks all correct. Click next. So here this is gonna be the output for our POSPac. And pretty much what we're gonna want to do is match what we brought it in as. Otherwise, it's gonna put it in a different the LAS or the LIDAR in a different location. So what we can do is click grid. We'll do state plane 1983. Zone is going to be Alabama East. It should automatically pick up the datum for us. If not, it's NAT 83 2011. Ellipsoid, and make sure you select meter over here. Okay. Click next. This kind of gives you a summary of what's going on. If you were doing it's less information for a local copy of POSPac or an own unit, but if you're using a subscription, it'll give you those values here of what it estimates it's going to cost. Usually it's a pretty conservative estimate, and it's typically less than what it says here. We can just click submit. Now this is going to be one of the longer steps of the process. Make sure to click yes. As it creates this, as it runs this part. Let me see if I think it's only a couple minutes, and then it'll generate a report, and we'll go through some of the important aspects of that. While this is running, I'll show you the file that it's creating, kind of give you a reference, and where we'll be, if you're not running POSPac with me right now, where you'll be needing to look later. Oops. So in our training data, training data, sample the data of the dam, under raw cycles, under backups, we're running the 559 cycle. And I'll show you this a little again later. We'll do it twice with the 505. But this post-process trajectory file is what it's creating right now. And what you'll need to use import later if you're not running POSPac. But I'll show you that shortly. Okay. Once it finishes, it should say this, that it's completed and it's made a report. And if you want to view it, typically I say it will say yes, just to come here and make sure our flight's good. So there's a lot of information here. There's a lot of sections in this report. Then there's a few that we'll take a look at. And if you want to do more of a deep dive on this, here's an article on the knowledge base that kind of goes into each section and talks about them a little bit. So places where we're interested in, you may want to look at your satellites, make sure you don't have a whole lot of cycle slips. That could be in signs of an issue, but ours looks good. A lot of these charts repeat themselves and they're fairly similar. One place here, which we've already know from what we saw on the map screw, but this looks like our flight plan. At least make sure make sure it does. If it doesn't, then you know that you've got an issue. If you look on here, this is another place you can notice these spikes in speed. It's a little faster than we say now. I think we're saying, I told you get up to 9 meters per second and then let off. It'll probably float up to about 10 and a half. We used to go full speed, but we're notified from a PlanX to drop that down a little bit. But you'll notice that you can see it on both ends, our heading alignment maneuvers there. Let's see, what's the next one? Next one that's important is this section here. This is GNSS QC. You're looking at this number here, this fixed number. Typically you're wanting to see that at 100%, but if it's like 98%, you're probably still okay, as long, and you can also see when it was, if it's not 100, you'll see like a loss in satellite or something. If it's at the before the flight or end of flight, you're most likely, you won't have an issue, but you want to, that's typically going to be 100%. Forward reverse separation, kind of talked about this briefly earlier, but like I said, it processes the data, the solution forward and in reverse, so we want to make sure those match up pretty closely. If you see some spikes at the beginning or end, kind of like this, it's not too much of an issue because you're taking off and landing. That kind of can throw this off a little bit, but that's not the data we're interested in anyway. So next spot. Let's see. Oop, I passed it. Smooth performance metrics is another one we want to look at. Make sure our northing and easting is fairly low, under 2 centimeters. Even a little lower most of the time, and our Z under 3, sometimes under 2, depends on the sensor. Make sure that looks fairly consistent. Spikes at the end and beginning, like I said, are not a real big issue with this. Everything else, not too interested in. Last section is just the export, so yeah, that's about all I typically will look at with the POSPac report. So what I can do now, and if you didn't run POSPac, you can still run this part right here, as this next icon here, just auto create flight lines. And we can auto create them or manually create them. And I'll go ahead and say one of these lines is going to give us an issue with on a turn, and I'll probably manually create. Actually, it might be on the next cycle, but I'll check. If you click this, it should bring up this dialog. I think the default values are 100, maybe 1 and 10. If I run these, what you'll notice, what I'll typically do after I run it, I'll close that and I'll turn off my trajectory points. What you'll notice is I have some gaps in my lines. So the setting that's going to affect that there is this max deviation. So this is how much it'll deviate from a straight line before it'll create a new one. We know this is a single line. So say if I bump this up to say 50, what it'll do is it'll you'll see that my gaps are gone. Let's see, but I also got some lines in here that are we don't need. There's a couple ways you can get rid of them. This is typically how I do it. What I'll go to is you'll have this toolbar here. It's called feature edit. Like I said, if it's not turned on, just go to your view and turn it on. We'll grab the select tool, which is the first one. And typically what I do while I'm holding control is I'll go select my lines that I don't want, and those are going to be our turns. Of course, there's our heading alignments, and then parts of this we're not interested in, which is most of our transit lines. And I can just hit the delete key, and it'll let me delete those. What I'll also do while I'm here, I'm gonna go ahead and delete this line. You don't have to do this. I'm just gonna show you how to do the manual creation of lines. Click yes. So what you'll need is your trajectory points on. With that select tool, as you do is you hit the beginning of your line or end, either way, and then hold Control and hit the opposite end. So make sure that both points are selected. And then what you can do, it is on a different toolbar. It's this flight line with a pencil that's along with the archive manager here. It's called create flight lines from selected points. If I click that, it'll put me a line in there right where I say it is. We'll use that later on the next cycle. I know it gives an issue, so. Okay. So next step here, this third option, create True View trajectories. So this is where you're gonna import that post-process trajectory file if you didn't run POSPac with me. To do so, all this would be empty. All you do is click import, go to the training data, so the dam, raw cycles, backups. This is 559. You just click that, select and open, and bring it in here. So the other part of this tab is the calibration. You'll see this calibration file. More than likely, and what's going to be you'll see these are diagnostic, and they say that for a reason, but they're there so if you have another calibration that you need to use for whatever reason, maybe debugging or troubleshooting, you can. But typically you'll even use this latest calibration from Reckon. So all of our calibrations for the sensors are housed on Reckon, and EVO will pull those down for you for cases similar to like this. You'll notice that the cycle residence, so that's the calibration file that was on this sensor when it was flown, is dated at the 8th of April, and the latest calibration was a couple days later. And so if we would have used the one that was on the system itself, it would have been using an older calibration. So typically what you're going to want to do is just leave it on this, and that's the default option anyway. So calibration is an important aspect of any LIDAR system. They have to be well calibrated, and this generally refers to ensuring that the hardware itself is properly bore sighted. Essentially, this is a way to the way at least I interpret is how make sure that it's say that again. So the way I interpret this means that the laser reference frame and the POSPac reference frame are aligned, and that the lever arms are correctly understood, so that when you're generating the actual data from the trajectory, you have the correct lever arms and so on and so forth. So that essentially ensuring that the system itself, all the different subsystems are properly calibrated, both in the reference frame and also in time. Also refers to minimizing the systematic errors. So there will always be some residual systematic error, just in any sensor. That is, there's going to be some error contributions that you're just not going to be able to eliminate completely. So there's going to be some residual error in the system, but we do want to minimize it by making sure everything is well calibrated. So the way we do this with True View, like I said, is we'll give you this factory. This calibration is done in the factory, and housed on Reckon for you just to grab from here. If you ever send in, the only reason you would need it to be recalibrated is you're seeing issues with the data after a while, I can't give you a good time frame, but you can potentially see some issues in calibration. There's what we can do. There's a couple things. You can either send it in to us, we'll calibrate it, or we can help you to plan out a mission, a calibration mission, and you can send it to us and we'll calibrate and get that up and running for you. And there's a time factor to that. I don't have a hard time with that. There's also, if say you had a hard landing or a crash, generally that's the only time when that calibration isn't going to hold, because of course you're moving things around in that sensor. That might be the time that you would need a recalibration. But Reckon holds a history of all the calibrations, whether it is owned or a subscription unit. So, and EVO will automatically communicate with that during the processing. And it does that with our serial numbers, of course. Okay. So the next option here is what photos it's going to retain. We're only interested in the ones with the flight line, but you can, if you wanted the other images, you can get them. We're typically only worried about the ones on the flight lines. That's what our optional pick. On this last section here, this update photo EXIF. So this is kind of a quality of life edition. It used to be, you'll see there's a button here, this tag with a pencil. It's still there. You're still able to update your EXIFs. That way, if you uncheck this or something, you're able to do that. But this kind of gives us one less step to have to click. Now if I create trajectories, it's gonna grab my calibration and then update my EXIF tags. Okay, it'll ask me if I want to tag my photos. Of course I do, so I click yes, and it'll start tagging for me. Okay. Once that finishes, we can click OK. So let's see. So what I'm going to do, so now we're ready to generate our LIDAR, actually get that data in. What I'm going to do is I'm going to kick this off, and then after I kick it off, we'll take a quick 15-minute break while it's working on that, because it does take a little bit of time, not too long. The colorization takes the longest, but it's not too long, depending on your hardware though. It can take longer or shorter than others. So that is, to do this, that's our next button on this geocode LIDAR. So we can, if we just want to do certain flight lines, we could select our flight lines and only geocode those. If you wanted to, we're going to be doing all of them, so we'll leave that unselected. So this is the part where I was talking about clipping earlier today. You know, we're gathering all that 120 degree field of view, collecting that of the LiDAR, but we're going to clip that down to typically what we recommend, which is 40 degrees plus or minus from nadir. So that's what we'll leave on. Okay. All right, so this enable true track. I'll talk about that a little bit. So what true track does is it kind of takes the I guess dynamics would be the good word of the aircraft kind of out of the processing. So if you think of it in an extreme case, you may have 2 to 3 degrees of roll to one side, and what true track does is it basically, when it's processing that data, it takes that roll out of it, and so essentially it keeps the swath width centered around nadir and compensates for some of the aircraft dynamics. So that's kind of what true track does. So this next option here, this is kind of another quality of life thing where it just skips another button click. So it'll automatically colorize the point cloud after this. If you don't want that on, of course, you can turn it off. But I'll go ahead and kick this off. Click yes. Any questions up to this point? Okay. So while this is processing, take probably like a 15-minute break. So it's 1:32 here, Central Time. So about I'll just say 10 minutes till, or well, yeah, 1:50 about Central Time. That should be good enough. And we'll meet back here and we'll continue on. And we'll process going through to do another cycle and do some bring in the ortho and do some vertical horizontal checking. And that should be most of what we've got for the day.
I do have a quick question. I had a little bit of trouble